Okay, this is number 33 on lesson 2.4, and we are looking at this function and we want to find all the zeros. And normally I would want to check Descartes' rule of signs, and I'd want to check the rational roots theorem to start getting an idea of what roots I can expect from this function. However, they have given me a root, which means I can just go ahead and start reducing this function down to a lower degree by using synthetic division to divide by 2 minus 5i. Because I know that if 2 minus 5i is a root, then 2 plus 5i is also a root. And so I can divide by 2 minus 5i, and I will get this down to a cubic equation. And then when I divide by 2 plus 5i, I'm going to get this thing down to a quadratic. And so I don't really need to check all those things like I normally would. Because given this is 0, I'm given another 0, and then I can use a quadratic. So I don't need to do any of the rule of signs or the rational roots theorem. The only hard part about this will be doing the division, because 2 minus 5i, it's not fun to divide by that. So that's what we're going to do. We're going to start out by dividing by 2 minus 5i. So our coefficients are 1, negative 4, 22, 28, and negative 203. And so we'll bring down the 1 and multiply 1 times 2 minus 5i, which is 2 minus 5i. And then we'll add that to negative 4, which will give us negative 2 minus 5i. And then we're going to multiply negative 2 minus 5i times 2 minus 5i. I'm going to do that over to the side just because it's not something that I can easily do in my head. So it looks like this. And 2 times negative 2 is negative 4. And then I'm going to have negative 10i and positive 10i for my middle terms. So that just ends up being 0. And then 5i times 5i, negative 5i times negative 5i is positive 25i squared. So that's negative 4 minus 25, which is negative 29. And then, so that's what I'm going to put right here. If I add that, I get negative 7. And negative 7 times 2 minus 5i is negative 14 plus 35i. And I'm going to add that to get 14 plus 35i. So I need to multiply 2 minus 5i times 14 plus 35i. So 2 times 14 is 28. 2 times 35 is 70i. And then you've got minus 70i minus 175i squared. So 28 plus 175 is 203, which is what we expected. And that means that we did this correctly, which is important because now we're going to use these coefficients to divide by 2 plus 5i, because we also know that is a root. So 2 plus 5i, we're going to divide that into these coefficients here. Negative 2 minus 5i, negative 7, and 14 plus 35i. So I'm going to bring down the 1, multiply, that's 2 plus 5i, which is going to give me 0. And then I multiply by 0 and I get 0. Bring down the negative 7, and that is negative 14 minus 35i. So that is 0. So I'm just left with this equation, x squared minus 7. I can figure out the zeros of that. They would be plus or minus the square root of 7, because 7 square root of 7 squared is 7. 7 minus 7 is 0. So the zeros for this are 2 minus 5i, 2 plus 5i, and plus or minus the square root of 7. Part B wants us to write the factorization, and that's very simple because if a number is a root, we know that x minus the root is going to be a factor. So we know that our factorization is going to be x minus 2 minus 5i times x minus 2 plus 5i times x minus the square root of 7 times x plus the square root of 7, or that's x minus negative square root of 7, so x plus the square root of 7. So that's the factorization of f of x, and the the solutions to the equation f of x equals 0 are the zeros. So they are just 2 plus or minus 5i and plus or minus the square root of 7. Okay, this is number 35 on section 2.4, so the next one. And again, they're giving us that 4 plus I is a 0. And so we also know that 4 minus I is a 0. And so again, I'm not going to use Descartes' rule of signs or anything, because all I have to do is divide by 4 plus I. So 4 plus I, dividing that into these coefficients. And so I'm going to bring down my 3 and multiply 12 plus 3i, and that is going to be negative 16 plus 3i. And then when I multiply that by 4 plus I, which I'm going to do over here to the side, I'm going to have negative 64 plus 12i minus 16i plus 3i squared. And so that's going to be negative 64 minus 3 is negative 67, and then minus 4i. So that's going to go here. 16 minus 4i times 4 plus I am going to get 64 plus 16i minus 16i, and then minus 4i squared. So 64 plus 4 is going to be 68, and that's going to be 0, which we knew it would be. All right, so we've got 4 plus I, and we want to make sure that that is 0, because if it isn't 0, we made a mistake. It's not that, anything else is wrong, because they told us 4 plus I is a 0. So it means we made a mistake. We need to go back and fix it. All right, so I know that 4 minus I is also a root. So I'm going to use the coefficients I got after dividing by 4 plus I. I don't need to go back to the original equation. I want to use these coefficients because it's going to be easier. Bring down your 3. So 12 minus 3i. So that is going to be negative 4. And negative 4 times 4 minus I is going to be negative 16 plus 4i, which is going to be 0. So all I'm left with here is 3x minus 4. So the number that makes that 0 is going to be 4/3. So my zeros are going to be 4 plus I, 4 minus I, and 4/3. So to write the factorization of this, I'm going to say x minus 4 plus I, x minus 4 minus I, and x minus 4/3. Then the solutions to f of x equals 0 are the zeros, 4 plus I, 4 minus I, and 4/3.